looking at point of inflection and how to determine point of inflection of a curve. In our first class today, we talked about how to sketch and how to end that life so we can move into something else entirely. In this class, we'll be looking at how to find a point of inflection. Point of inflection. We say we have 3 points of consideration in the curve. We have the minimum point, we have the maximum point, we have the point of inflection, Okay, these 3 points are also called stationary points. And one thing we should take note is that these 3 points obeys the 2 conditions under turning point of a curve. The first condition we said we have the necessary condition, right? And we have the sufficient condition. Please take note. In the necessary condition, we say that the first derivative, dy dx, at the turning point must be equal to 0. Here, we have to differentiate further the 2y over dx squared. And when the value is greater than 0, we know what it means. When it's less than 0, we know what it means. When it's equal to 0, it means the point of inflection. When the second derivative is greater than 0, it simply means we have a minimum turning point. When it's less than 0, we have a maximum turning point. When the 2y over the x squared is equal to 0, we have point of inflection. Then, what is point of inflection? Point of inflection, by definition, is that point in a curve where the curve changes its concavity, or where the concavity of a curve changes. The points on the curve where the concavity of a curve changes either from upward toward downward or from downward toward upward. Like I said, if I have a maximum point and we have a minimum point, the point where this curve changes its concavity is called point of what? Inflection. We have the maximum, we have what? The minimum. We say that at the turning point, dy dx is equal to 0. Here, dy dx is equal to 0. At this point of inflection, dy dx is also equals to 0. Each of these points here obeys the first condition, which we refer to as the necessary condition. Okay, let's take note again that condition for point of inflection, condition for points of inflection. Okay, the first condition we mentioned is called the necessary condition. That says that the y dx must be equal to 0. The second condition says that the 2y over the x squared must be equal to what? Must be equal to 0. Then we have what we call steps. Steps used in finding point of inflection. The first step is to find the first derivative. Find the first derivative. Number 2 is to find the second derivative. Find the second derivative, which we call the sufficient condition. Number 3 step is to set. We have to set the second derivative equals to 0. we have to set the 2y over the x squared to be equals to what? 0. And find x. And find x. When we set this, we have to find x. Don't forget that under minimum and maximum, the first thing we need to do under minimum and maximum turning point is that we find the first derivative, set it equals to 0, then find x. But when it comes to point of inflection, we have to find the first derivative function, find the second derivative function, then we have to set the second derivative function equals to 0, then find x. That value of x we got, we'll substitute back to the original function to find y. Are you there? Just like the same way we did for that of minimum and maximum. Just that in this case here, we'll differentiate down to the second derivative. Then we substitute the value of that x into y to get the coordinate. Are you there? Then we test. Number 4. Okay. Number 4, we find x and y. Don't forget, find x and y. Find x and y. Number 4, also find the coordinate point. The coordinate point. Number 5, we have to test slightly to the left and right. I will explain that when I bring up equation. To the left and right of x in the second derivative to confirm the sign changes. We have to test slightly to the left and right of x in the second derivative to confirm the sign changes. If the sign changes from negative to positive, from positive to what? Negative, that means there's a point of what? Inflection. But if the sign did not change, if the sign remains the same, it means there's no point of what? Inflection. Let's look at the first question, which was the assignment I gave yesterday. Please, if you're online, want to join this live class, just click on the like button. Click on the like button. Click on the like button. Please click on the like button. Question number 1 says that we should find the point of inflection of y equals to s cube. Of y equals to s cube. Solution to this. The first thing we need to do is to differentiate. The first condition says necessary condition that at every turning point, the y dx must be equal to 0. So I have to differentiate this. Differentiating, it means my dy dx will give us what here? 3s squared. You know, if I'm to find my maximum turning point and minimum turning point, after differentiating, I will set this equals to 0, right? But because I'm looking for point of inflection, point of inflection says that the 2y over what? The x squared must be equals to what? 0, right? So that means I will have to differentiate further, then set the function equals to 0 to find x. Then any value of s we have, we put it back into this y to find the coordinate points, right? So let's go. So here we have also the 2y over the s squared becomes 2 times 3, will give us 6x. Then we have to set our the 2y over the s squared equals to what? 0. To satisfy the point of inflection. So when we set this equals 0, that means our 6x is equals to what? 0. By the time we set this equals 0, to find the value of x, I will divide both sides by what? By 6, Abi? By 6. So this can go. So my x is equals to what? 0. Now, the next is to put x equals to 0 in the function. And and the function is our f of x, right? Which is y. To find y, it means y equals to, recall that y equals to s cubed. So y is equals to, our x is 0 to the power of 3, which is 0. Therefore, the coordinate point, which is our s comma y, is 0 comma what? 0. This alone is not enough to say that y equals to s cubed is let's say, sorry, this alone is not enough to say that the point of inflection is 0 comma 0. Don't forget that when we find the value of our x, we got x as what? As 0. I have to test for this x. How do we test? I will test to the left and to the right. That was the reason why I gave us a note that says that the steps, we recall again, don't forget the steps. The first step to determine point of inflection is that we have to find the first derivative. Number 2, find the second derivative, which is the 2y, the s squared, which we have done. Number 3 is to set the second derivative equals to 0, which is what we did here. We set this equal to 0, we have our x as well 0. And solve for x, which we did, our s is 0. Then we substitute s back into the original equation to find the corresponding value of y, which we did, and y gave us was 0. Y equals to s cubed. When we put our x as 0, we have what? 0. 0 to the power of 3 is still 0. Then the next is to find the coordinates, which we have done. The last step says test value. Test value slightly to the left and to the right of x in the second derivative to confirm the sign changes. Now listen. To test, the value of our x here is obviously 0. If I'm to bring up my number line and we have 0, to the right of 0, I will subtract 1. I will just come here as minus 1. To the left, rather, of 0 is minus 1. To the right of 0 is what? Is 1. I will just subtract 1 from 0. That will give us left, right? Left value here is minus 1. I will add what? 1 to 0 to form the right value. Some materials, they will just subtract 0.5 and add what? 0.5. But yeah, I'm just using 1. Throughout your point of inflection, if you have to test for s, always use 1. If I have, let's say if I have x, if x is equals to 2, for instance, so here will be what? 2. To the left will now be what? 1. To the right will now be what? 3. When you subtract 1 from 2, we have 1. When you add 1 to 2, we have 3. Are you there? So since our value of x is actually equals to 0, so that means that to my left is minus 1. To my right is what? Is 1. Okay, so what we do here is to test for the left. To the left, okay? Test for the left side. Okay, when we test for the left side there is x equals to minus 1, right? S equals to what? Minus 1. Okay, s equals to minus 1. What do we do here? I will put the value of my x as minus 1 into the second derivative function. I'm testing. Don't forget that whenever your second derivative is negative, it means we have a maximum point, right? Maximum means it is open downward. Is that clear? If the value of the 2y or the s square is positive, it means we have a minimum point, meaning it is opened upward. It is concave upward. We have concave upward and concave downward. When the function is this way, this is called concave upward. When it's this way, this is called what? Concave what? Downward. When it's this way means we have a minimum. That means our d2y over what? The s square is what? Is negative. Abi? It's negative, meaning it is less than 0. Any number less than 0 is negative. Don't forget. But for this simply means that, sorry, this is positive. I'm sorry. This is positive, right? Positive is for minimum, right? When it's greater than 0, we have a minimum. That means it is concave up. When it's concave down, it means that our d2y over what? The x squared is what? Is negative. So maximum turning point is always negative in the second derivative. Minimum turning point is always what? Positive. Don't forget. So let's see, let's test. So in this test now, let's see if there is a change in sign. Once there's a change in sign, that means that point of inflection occur at this. So for s equals to -1, our d2y over the s squared will give us, let's see, that will give us 6x. We have the 2y over the s squared as 6x. It means I'll put my first value of x as -1 into the 6x. That will give us 6 times -1. And the result is what? -6. -6, is it less than 0 or greater than 0? It is less than 0. And when this is less than 0, when the 2y over the s squared is less than 0, it means that we have a maximum point. I mean, a maximum point. Okay, meaning it is negative. Maximum is negative. Don't forget. So the next is to test for the right hand side. We have to test for the right hand side. We are testing for what now? In the comment section, please tell me, what are we testing for in the comment section? We are testing for s equals to 1. For x equals to 1. When we test for s equals to 1, that means our d2y over the s squared is equals to 6 times 1. And 6 times 1 is 6. This is plus 6. Okay. Plus simply means what? Minimum, right? Minimum. Minimum simply means negative. Don't forget. Minimum means negative. Okay, it means negative. Minimum simply means it is concave up. This is concave up. This is concave down. This is open downward. Okay. Now, since there's a change in sign, since there's a change in sign from negative to positive. When we put the value of -1, we have minus as negative, which is maximum. Okay? Then here we have what here? Positive. From negative, or let me use this sign, from negative to positive. Okay? Therefore, point of inflection occur at 0, what? 0. That is how simple this is. That is how simple this point of inflection is. All we just need to note is the steps. If you can take note of the steps, you can be able to determine if there's a point of inflection or not. What do you notice? That means we have a maximum point at some point in the curve. Let me show us something. It means that this curve is something of this nature. This curve is something of this nature. But the point where this curve here meets the x-axis and the y-axis is at the origin. It means it meets both the x and the y at the what? At the origin, where we have 0, 0. So we have the point of inflection somewhere here. Exactly. That's what it means. It means it is changing from negative to a positive. Maximum is negative. This is what? Positive. That's what it means. So if you don't test for this and this, you can't determine this. That's why we are testing. -6 means maximum. When the 2y over the s squared is negative, it means maximum. When the 2y over the s squared is positive, it means we're minimum. That means that the sign changes from negative, from being maximum to minimum. And that point where these two, where we have our point of inflection is what? At the origin, which is 0, what? 0. Let's see example 2. Please, if you are following, indicate in the comment section. If you are following, indicate in the comment section. If you are following, indicate in the comment section. Once you join, just like the video. Once you join, just like the video. Okay, next question says that determine the points of inflection for the curve. For the curve is given as y equals to s cubed minus 6s squared plus 12x minus 5. All right, I'm going to pause this video for 2 minutes. Within 2 minutes, please find for me the first and second derivative of this function. Then when you find the first and second, solve for x. Okay, find the first derivative, find the second derivative, then equate the second derivative equals to 0, then solve for x within 2 minutes. Let me pause the video. Okay, anyone yet? So solution to this, let's go. Let's find the first derivative, dy dx. Dy dx will give us 3s squared minus 12s plus 12, right? The next is us to find, we find the second derivative, which is the 2y over the s squared, and that will give us what? 6s minus 12. Then the next is to set the 2y over the s squared, which is 6x minus 12 equals to what? 0. That will give us 6x equals to what? 12. To solve for s, we divide both sides by 6, right? By 6. This will give us what here? X equals to 2. Is that clear? Okay. Now the next is to put our x. Put x equals to 2 in the original function. In the original function. To find y. To find y, right? And that will give us y equals to, here we have 2 to the power of 3 minus 6 times 2 to the power of 2 plus 12 times 2, okay, minus 5. So let's find the value of y. This will give us 8. We have y equals to 8 minus 6 times 4 plus 24 minus 5. So let's go. So we have 8 minus 24 plus 24 minus 5. So our y is equals to 3. Okay, so that implies that the coordinates points is actually when x equals to what? 2. When x equals to 2, y equals to 3. The next is to test for x. We have to test for x. In this case here, our x is 2. Our x is 2. Let's verify if our point of inflection occur at 2, 3. We test for 2. Let me bring out 2 here. To the left of 2, when you subtract 1 from 2, we have 1. To the right of 2, we have 3. Don't forget, this is our left. This is what? Our right. So let's see if the sign changes. To the left hand side, okay, to the left hand side, to the left, let's test for x. We are testing for the concavity, okay, of the curve. Test for to the left is x equals to 1, meaning I'm going to put my x as 1 in the second derivative function, which is this, right? I'll put my x as 1 there. Let's see. Let me take off this. Okay, let's test. That will give us our d2y over the s squared equals to 6 times 1 minus 12. This will give us minus 6. Minus 6. 6 times 1 is 6. 6 minus 12 is minus 6. So let's test now to the right. To the right. For this, hope we know what this implies. This simply means maximum, right? It means maximum or concave down, right? Maximum, which is negative. The sign is negative, yeah? So to the right is s equals to 3. S equals to 3. Let's verify. So the 2y over the s squared will be equals to 6 times 3 minus 12, right? Here we have 18 minus 12. The answer is plus 6. This simply means minimum, right? Minimum, which is also same as what? Positive. Since the sign changes from negative to positive, it means that point of inflection occur at what point? At 2, 3. Since the sign changes from negative to positive, therefore, points of inflection occur at 2, 3. This is verified. We have verified it. Okay? This is correct. It occurs at 2, 3. It must not always be negative to positive. It can also be positive to negative. But if these two signs are the same, it means there is no point of what? Inflection at that point. Are you there? Okay. So let's see one or two examples. Okay, next question says that next question says, find all the stationary points of the curve and determine their nature. Find all the stationary points of the curve. We have y equals to s cubed minus 3s squared minus 9x plus 1. Okay, by now we understand is a find all the stationary points, meaning find the minimum point, find the maximum point, and find the point of inflection. Okay, in our previous class we have done this. I'm not going to repeat this because we have already done this. We have also done this. So let me just solve for point of inflection. So on your own, you can find the minimum and maximum points while I find the point of inflection. Please, if today is your first time in this class, okay, we did the class. We have already learned how to find the minimum points and maximum turning points of a curve. So you can always go back to the YouTube videos, okay? So just go back to the video, search for minimum and maximum points by EMI-BRAIN, you will see it there. Okay, solution to this. Let us find the point of inflection. Question says find all the stationary points, meaning find these 3 points. So I'm going to solve for only point of inflection. So the first thing we need to do is to differentiate, right? We have to differentiate the function, right? The function, meaning we have our dy dx, that will give us 3x squared minus 6x minus 9. We have to further differentiate again, right? We differentiate again. Also, we have to find our d2y, because point of inflection says that the 2y over what? The x squared must be equal to 0. So I have to find this and find the value of x for this expression. So let's go. So we have the 2y over the x squared. That will give us 6x minus 6. Then we have to set. We set our d2y over the x squared to be equal to 0. So that means 6x minus 6 is equal to 0. So 6x is equal to 6. From here, we can find the value of s by dividing both sides by 6. So that means our x is equal to what? 1. Then when we get the value of x as 1, we have to find the corresponding value of y. So we say put x equals to 1 in the original function. The function here says y equals to s cubed minus 3x squared minus 9x plus 1. So that will give us y equals to 1 to the power of 3 minus 3 times 1 to the power of 2 minus 9 times 1 plus 1. So y is equals to 1 to the power of 3 is 1, right? 1 to the power of 2 is 1. 1 times minus 3 is minus 3. Minus 9 plus 1. Okay. So let's see, what do we have there? One minus 3 minus 9 plus 1. The answer is minus 10. So y is equals to minus 10. So that means the coordinate points for the point of inflection, the coordinate point will be when x is 1, then y is minus 10. So let's verify. Let's test for this. Let's test for the concavity. Test for concavity. Test for concavity. Okay, so what we do here, we bring out our value of x as 1. To the left is 2. When you add 1 to 1, we have 2. Right? Sorry, is 0 rather. We subtract 1 from 1. If our x is 1, to the left will be 0. To the right will be what? 2. We are testing. This is our left. This is what? Our right. So let's see if the sign changes. Okay, so for when x equals to 0, we are testing for the left. So for the left, s equals to what? 0. Let's see what we are going to have. If s equals to 0, so let's go. Our d2y over the s squared. The 2 over the s squared is 6s minus 6. So that will give us 6 times 0 minus 6. The answer is minus 6. This is negative, right? Negative means minimum. This is negative. Left is negative. Don't forget, left is negative. Let's look at the right hand side. For the right is x equals to 2. S equals to 2. Let's look at the right. Okay. So that means our d2y over dx squared will give us 6 times 2 minus 6. Here will give us 12 minus 6. The answer is plus 6. Plus 6 is greater than 0. So this will give us our minimum, right? This is minimum. Sorry. Minus 6. This is maximum. I'm sorry for that. Maximum. 6 minus 0 is 0 minus 6 is minus 6. Minus 6 is actually maximum, right? Don't forget. Maximum, which is negative, right? Good. It's negative. The main thing is that the sign here is negative. The sign here is negative on the left-hand side. Let's verify this. The sign here is what? Is positive. That's the main thing. So since the sign changes from negative to positive, since the sign changes from negative to positive, the point of inflection occur at 1 comma minus 10. All right, so let's look at one more example. Please, if you join us, ensure you like the video so we can reach out to more people. The more we like, the more we have more visibility. Please ensure you like the video. Let's look at more questions. All right, let's look at more example. So let me get some questions from past question. Okay. The question here says that we should find a point of inflection of this function y equals to x cubed minus 9x squared plus 7x. X cubed minus 9x squared plus 7x. Okay, that is the function here. Solution to this, and now we know better. What we have to, the first thing we need to do here is to find the y dx, right? We find the y dx of this function will give us again 3x squared minus 18x plus 7. The next is to find the second derivative, which will lead us to the point of inflection determination. So here we have here as 6x minus 18, right? Minus 18. The third is to set the 2y over the x squared to be equals to what? 0. Equals to 0. So that will give us, let's check this out. This will give us 6x minus 18 equals to 0. So we have 6x equals to what? 18. By the time we divide this by 6, our value of x is equals to 3. So the next is to find the corresponding value of y, which is find y, right? Yeah, our y is equals to, I will substitute the value of 3 here. That will give me 3 to the power of 3 minus 9, 3 to the power of 2 plus 7 times 3. So here we have 27. 3 to the power of 3 is 27. So y is equals to 27 minus 3 to the power of 2 is 9. 9 times 9 is about 81. Plus 21. Okay, so let's subtract 27 minus 81 plus 21. This will give us a y equals to minus 33. Therefore, the coordinate point is x equals to 3, comma minus 33. So let's verify. Let's verify the concavity test for the concavity, right? Concavity. Let's verify this. The value of x here is 3. Let's bring out 3. To the left is 2. To the right is 4, right? Here we have left. We have what here? We have right. So let's see. To the left, I'm going to say put x equals to 2 in the 2y over what? The s squared, right? So let's look at what will be the result. What will be the result? We put 2 over the 2y over the s squared. Oh, I've cleaned already. Excuse me, let me get the function again. Over the 2y, recall that the 2y over the s squared is 6x minus 18, right? 6x minus 18. So when we put x as 2, that will give us the 2y over the s squared equals to, here we have 6 times 2 minus 18. This gives us about 12 minus 18. The answer is minus 6, right? Minus 6. And this is negative, right? This is negative. So the left hand side is negative, is minus. Let's verify. Also put x equals to, on the right hand side, I'll put x equals to 4 in the 2y over the s squared, right? So that will give us here the 2y over what? The s squared equals to 6 times 4 minus 18. Okay, so 6 times 4 is 24. So we have 24 minus 18 should be 8, should be 6 rather. So we have the 2y over the s squared is equals to plus 6. This is positive. So here we have positive. So the sign changes from negative. This is the points, our value of x. It changes from negative to what? To positive. Since there's a change in sign, since the sign changes from positive, from negative to positive, it means a point of inflection, right? Of inflection occur at 3, minus 33. Put this down. Okay, this is just how to find point of inflection. Now let's see one more example. What if we are given this function y equals to, let's say, x squared plus 5x plus 6, and we also test for the concavity to find the point of inflection of this function here. Okay, now let me don't give this, because already this cannot even, there's no point of inflection because I have a quadratic function here. Let's see if I have, let me get an equation that has x to the power of 4. Let me check if there's any one of that kind. Okay, let's see this question here that says that test the function y equals to x to the power of 4. Y, if we are given y equals to x to the power of 4. Okay, so let's see if we're going to have a point of inflection here. Let's see, solution to this is to find the first derivative, which is our dy what? The x, that will give us 4x to the power of 3, right? Second is to find the second derivative, which is the 2y over the x squared, which is about 12x to the power of 2. The third is to set the 2y over the x squared equals to 0, meaning I'm going to set 12x squared equals to 0. So to find the value of x, my x squared equals to 0 over, okay, let's start by saying divide both sides by what? By 12, right? By 12. So this will give us x squared equals to 0. That means our x is still 0. So the next is to find the coordinates by putting x equals to 0 in the function, right? In the function, the function we have here is y equals to x to the power of 4. So let's see what will be the result. Sorry, this board is very small. Please manage. You guys should manage with me. Now let's see. X equals to 0. By the time we put our x equal to 0 in the function, it means y should be equal to 0 all to the power of 4, which is also 0, right? Therefore, the coordinates will be 0, 0. So let's verify if we're going to have a point of inflection here. Let's verify. So we're going to test, right? Test for the concavity. Concavity. Okay. The value of x is 0. S is 0, so we have 0. To the left is -1. To the right is what? Is 1. I can also choose -0.5 and plus 0.5, like I said. But I always prefer subtracting 1 and adding 1. So let's see. Let's see what will be the result here. Okay, so we have to put, we put x equals to what? -1 and the 2y over what? The x squared. I will say when, let me just say when, sorry. When x equals to -1 to the left, right? This left and right, -1. So that means our the 2y over the x squared will give us, the 2 over the x squared is 12x squared. That will give us 12 times -1 all squared. The result becomes plus 12. Here we have positive. And this value is greater than what? 0, right? Here we have a minimum point here. Minimum. Or we say we have positive sign. Have we? Our sign here is positive. So we have a minimum point. 12 is greater than 0. So minimum turning point occurred here. So let's see. Okay. So when again? When x to the right, s is 1. To the left is -1. We have seen the value is 12. To the left, to the right now, when s equals to what? 1. Let's see our d2y over what? the x squared is equals to 12 times 1 to the power of 2. The answer remains plus 12. Plus 12. And plus 12 also represents minimum because 12 is greater than 0, right? So this is also positive. This is positive. So to the left is positive, to the right is positive. Since the sign did not change, it means there is no point of inflection. There is no point of inflection at 0, 0. There is no point of inflection at 0, 0 because the sign remains the same. The sign remains the same. For this, we have positive. This, we have positive. Okay, but there is a minimum turning point. Turning point at 0, 0. What we said, we have a minimum. The sign here is positive. 12 plus 12 is greater than 0. We have minimum. Here we also have what here? Minimum. So that means that there is no point of inflection because the sign did not change. But there must be a turning point. The turning point there is what? Is a minimum turning point because the sign remains the same. All right, so that is just how to solve for this. Okay. All right, I think I'm going to stop here for now. So we are done with this class. We are done with everything about turning point of a curve. We have seen the minimum turning point. We have seen the maximum turning point. So my class will end now. Our next class will be in the morning at the tutorial center by 8 a.m. For those of you who attend Imo State University, please ensure you join us tomorrow on integration. So our next online class will now be on integration, no longer turning point of a curve. Please ensure you share the link to your course mates to also have access to this class. All right, thank you guys. So see you guys tomorrow.